Okay, so we've got a sort of challenging question here where they give you the area, okay, of this patio. And you've got to think of this patio as sort of like starting off with the larger sort of sector here, okay, which would be the whole thing here, and then you're cutting out this smaller sector, which I've tried to draw here. Okay, so they give you all the values here, so we know, for instance, that's 20 meters from O to C, and of course then the smaller sector then is O to D is 7 meters. So essentially, if I start off with the larger sector and then work out the area and then take away the area of the smaller sector, it should equal to 199.1. So if you consider them separately here, if we look at the larger sector first, so the area of this, for instance, would be a fraction, okay, of the full area, yeah, of that large circle. So the fraction is going to be x over 360, okay, because I've called it angle x there, out of the whole, which is 360, times then, okay, because area of a circle is pi r squared, isn't it? So it'll be 3.14 times 20 squared. Now, we're just going to have to leave it like that, right? Or perhaps we could simplify this a bit here. Maybe if we work out 3.14 times 20 squared, so we'll have 1256 there, okay? So because you're timesing it by x on you, so this is 1256 times x, so I'll write x over 360. So maybe we'll just leave it like that for a minute. If you do then the smaller sector, so x over 360, okay, the fraction then of the area of a full circle, which will be 3.14 times 7 squared. So again, if I do something similar there, if I work out what 3.14 times 7 squared is, so I get 153.86x over 360. And you just need to appreciate, as I explained before, this patio then is the big sector take away the little sector. So it'll be this take away this. And that will give you then the area of that patio, which is 199.1. And you take them away. Now, we can work backwards then to work out x. But what's simple here about this is the fact that these are both x terms, and you've got something x here, and we want to take away. So let's just take away these fractions. So start off with that fraction there. So we'll have 1256 over 360, take away fraction 153.86 over 360. So we left them with that, so 6123 over 2000x equals to 199.1. And then to get x, then you just got to think about dividing here. So take that over and times, and then because you times in by the 6123, take that over and divide. Okay, so you're doing a bit of algebra, doing the opposites when you take it over. So if I work that out, oops. I get 65 degrees. Okay, so part B then says, using your answer to part A, calculate the length of the perimeter of the patio. Well, if you look at the patio, we can determine that's going to be 13, can't we? Because, you know, we know that's 7, that's got to be 13, because the whole thing is 20. So this is 13 as well. So all I need now is the arc here, and of course the arc here. Okay, so the two arcs there. So this would be the arc of this here, going from A to D, and then the larger one then will be the arc going from B to C. But we know now, of course, this angle 65 degrees, that's what we're going to use. So for AD, for arc AD, the length will be, well, the fraction, isn't it, which is going to be 65 degrees out of 360 times then, because this arc, it's a fraction of the circumference, which is, of course, pi d for the circumference. So that will be 14. It's pi times the diameter. Diameter is going to be 14 because it's going to be double that, isn't it? So we've got 7 it's not particularly nice, 7.9. but we round to 1 decimal place, and then we do the same then for the arc BC. So it's the same fraction. But this time the diameter is going to be 40. So I get 22.7. So then the perimeter then, we'll add those two arcs together, plus then the 13s we discussed earlier. So we get 56.6 meters.